Hello everybody and welcome to this video in our series about graph data science. In this video we're going to learn about path finding algorithms, which are generally used to try and find routes between pairs of nodes, and they typically build on top of the graph search algorithms that we learned about in a previous video. So let's have a look at what algorithms we've got to work with. So these are some of them. So we've got at the simplest, I guess we've got shortest paths, and there are some variants on that as well. We've then got and the idea is that we're trying to find the shortest path between two nodes. And we've then got all pairs shortest path, and that's where we're trying to find the shortest path between every pair of nodes. Single source shortest path, find the shortest path from a specific node to all the other nodes. Minimum spanning tree, start from a node and find the shortest path that connects all the nodes that you can get to. And then finally we've got the random walk algorithm, which is where we start from a node and then randomly follow the relationships from there outwards. So let's start with the shortest path. So the idea with this one is that we're trying to find the shortest path between a pair of nodes, and that can either be a weighted or unweighted path. So an unweighted path would be we're trying to find the shortest in terms of number of hops or in terms of number of relationships between the pairs of nodes, and a weighted one would mean we're trying to find the minimum costs. So by looking at the weights on each relationship, we try and find the minimum cost path between the nodes. So this is quite a commonly known algorithm. So this would be the one that if you're using some Google Maps, it would be using some sort of variant of shortest path. If you say, hey, I'm at this location, show me the quickest way to get somewhere else. That would be a shortest path search. Or if we were trying to do the Kevin Bacon question, so show me the number of degrees separation between an actor and Kevin Bacon, that would be a shortest path search as well. A star is a variant of shortest path, and this time instead of just working out shortest path on its own, we're using some extra information as part of a heuristic function. And normally that might be if we were doing a route-based shortest path, it might be that we have the latitude and longitude coordinates off the different nodes, and we can use that to try and guide us in the right direction. And so the output should be the same as the Dijkstra or as the normal shortest path algorithm, but it should be able to compute it more quickly. And again, the use cases will be similar. Another one then is the Jens K shortest path algorithm. And here, instead of just finding the shortest path, we're looking for the second shortest path, the third shortest path, and so on up to a specified value, so which we would call the K value. So this one's really useful if you want to see, okay, well maybe the shortest path that you show me is actually busy, and I want to know, show me some other routes. And Google Maps does this, so you see, like, here's my shortest path, but actually there are a couple of other ones as well. All pairs shortest path is is a different one, and so this time, rather than just finding the shortest path between two pairs of nodes, we want to find the shortest path between all pairs of nodes. And again, we can do weighted and unweighted variants. This one's obviously not really the type of query or algorithm that you're going to be running in a real-time situation, because it's got to do a lot of computation. But it can be useful for use cases like shown on the right hand side here. So if we were trying to optimize the location of some facilities and the distribution of goods, we could use it there. Or it's been used also to find on a network the maximum bandwidth and minimum latency as part of the data center design. Single source shortest path is another one. And here, rather than finding the shortest path between all pairs, we actually just have one starting node, and then we want to find the shortest path from there to everywhere else. So imagine we were trying to say, okay, we're in London and I want to know what's the shortest path to get to Manchester, what's the shortest path to get up to Edinburgh, what's the shortest path to Bristol. So I could get like the distance from one place to everywhere else. And so this one could be used for doing sort of testing a link failure in a topology to see if it can come up with a new route, or it's also been used in IP routing protocols. Minimum spanning tree is the next one. So this one is starting from a given node. I want to go to all of its reachable nodes, so all the subgraph that I can reach, and find the set of relationships that connect those nodes together in the minimum possible weight. And so this one might be useful for travel planning. So imagine we're trying to figure out a way to go around the country in the shortest amount of distance, or it's also been used to trace history of infection transmission, and as you can see, they're visualizing correlations between currency returns as well. And then our last one is the random walk. And so here, this is sometimes called the drunkard's walk. So it's like we're starting from a point, and then we randomly pick a relationship to follow. And so we might sometimes come back on ourselves, or we could be going in one direction and then come back. And so there are other variants as well where we can take the weights on those relationships into account. This one is usually used as part of other algorithms. So there are a couple of graph embedding algorithms that make use of random walks and community detection algorithms as well. And then it's also been used as part of machine learning models. Okay, so hopefully now you've got a good understanding of path finding algorithms. And just to recap, these are algorithms where we could be finding the shortest path between a pair of nodes. We could be trying to find the shortest path between all pairs of nodes. Or perhaps we're just starting from one specific node and we want to know the shortest path from that one to everybody else. And then equally with the random walk algorithm, we could just be trying to find some sort of random path through our graph.